Okay, everybody, hang on to your hats because we're about to do the chain rule in logic, and it's complicated. We're going to be doing this by looking at the truth table, and it's got a ton of columns, and so we're just going to have to be patient and work them all out. Now, to save some time, what I've done is started with the ones that are most obvious. So we have three things for the chain rule. Let me write down what the chain rule is because that it's always important to write down what it is that you're trying to prove. So we've got P implies Q and Q implies R implies P implies R. So this is what the chain aspect of it is. Idaho Falls Chuckers. Anyway, the chain aspect of it is we're not going to hold on to our heads. So this is how reasoning is done with this piece of logic right here. If I know that P implies R, and I know that, I'm sorry, P implies Q. I said the wrong thing. P implies Q. And I know that P implies R, that implies that P implies R. So this is one of the basic steps of reasoning, that given the truth of P implies Q and the truth of Q implies R, I know the truth of P implies R. So the truth table is going to be a little complicated. Now, I know it's going to be complicated because I've laid this out in letterbox format instead of portrait, and because there's going to be a ton of columns. And so we're just going to take our time and do them right. And the other ones I've filled in advance are P implies Q and Q implies R. The reason those are fairly straightforward is that P and Q are adjacent columns here. So there's no chance of skipping a line or something when you're going through. And the same with Q and R. And one thing that you can do when looking at any kind of logical situation, or almost anything to do with binary functions, is if you look here, we've got, for P implies Q, 1, 1, 0, 0, 1, 1, 1, 1. That's kind of a doubling of P implies Q. So every instance of the variables P and Q has appeared twice, and so we should get every instance of the values twice, and it's got the same pattern, 1, 1, 0, 0, 1, 1, 1, 1. The same thing applies to Q and R. Every instance of Q and of R has been done twice, so we should get the values twice, and now we get a repeat, 1, 0, 1, 1, 1, 0, 1, 1. So I'm very comfortable that these are correct because I'm seeing the replication of the pattern that one expects when doing these things. So I've done P implies Q twice basically. Okay. Now I've pre-filled a column that I'm going to call column A. You'll see why in a minute, and that's going to be the AND of the previous two columns. So AND is true if both of the previous two columns are true. And so I'm just going to go down. So that means when I have 1, 1, like we have in the first row, that means the AND is true. And anytime I have a 0, I know the AND is false. And so I get this situation here where really the first lines are true. That's the 1, 1s. And everything else is false. Everything else has a 0 in it someplace. So it's false. That's great. So I'm going to call that column A. And now we need to have another column that I'm going to call column B. And this is one that is physiologically tricky. It's logically straightforward, but physiologically tricky, and you'll see why in a second. Or if you sit down and do this out, you'll see why. You're going to make mistakes because you're going to jump a line, basically. I'll show you what I mean by this. So now we want to look at P implies R. And so that's one of the propositions that we're interested in this chain rule. So if we look at P implies R, the problem here is that we're not looking at adjacent columns. And so it's really easy as you go and write and go and write and go and write and go and write to end up back at the wrong spot. So one thing that you can do to kind of help yourself out in a mechanical or physiological way is block out everything except the column that you're working on And then when you look at P and R, then you can look at their implication. So I'm going to do that now. So P and R are both 1, the implication is 1. P is 1, R is 0, the implication is 0. P is 1, R is 1. I almost jumped a column here when I did that. P is 1, R is 1, the implication is 1. P is 1, R is 0, the implication is 0. Okay, now in the rest of them, I believe in shortcuts, as does every C compiler or Java compiler or whatever that works with ands. We know that 0 implies, who cares? It's true. So what we're going to get here for P implies R is that the last 4 are true. Now, that's what I'm calling column A. So column B was the and of the 2 given implications. Column B is the desired implication, and they're not the same. Never mind. We weren't claiming that they were the same. What we were claiming was that one of those, column A, implies the other, column B. So we have to look at the implication to determine what's gone on. And now this is going to be, actually this is kind of super easy because there's so many zeros in column A. But anyway, let's see what happens here. So I'm going to look at A implies B. A little bit of a side note here. What I've done is I've made up names for columns. This is like bundling stuff together, or this is almost like a subroutine, isn't it? You know, I've got the A subroutine that gives these values and the B subroutine that gives these values, and so I'm kind of chaining together. That's why they call it the chain rule. I'm kind of chaining together these implications, and if we look down column A, then we've got a 1. Oh, we might have to do some work with that. But the next 3 are 0, and that A is the hypothesis in a implication. So if A is 0, the implication's true. And that happens again down here. So I'm going to kind of do this as follows. I'm going to go, buh. I don't know yet. 1, 1, 1. Buh. I don't know yet. 1, 1, 1. So now all that remains is for me to look in the situations where A is 1. And now in this row where A is 1, B is 1. So the implication is 1. And we get the same kind of thing in this 5th row here. And so the implication is 1. And so for every value of P, Q, and R, the statement P implies Q and Q implies R gives the exact same value, it's true, as Q implies R. So this is the chain rule, and of course I'm going to take a picture of this and scan it because you can study it. And it wasn't really all that bad, so we can leave our hats on.